In this tutorial, the goal is to understand the Revit meshing environment and how to use it to create complex forms, such as Calatrava's Mediopadana Station. The tutorial will be broken up into 7 bite-sized chunks to help manage the complexity. This is the most important part of the process. Your effort and attention here will greatly impact on your final result. To help build the form, we should take some time to decipher it, and this is best done using 2 principles: understanding the form and hand sketching. For example, in this image, we get a great idea of how the form flows. If we simplify this shape, we get inclined zigzags. And then we can take this further by exploring it on paper. Sketch out the form to draw out the nuances of how it flows and to understand where the form flexes. This will help you locate which reference points and levels may be required. And of course, this doesn't have to be perfect. In step 2, we take all that we learned from the setup and focus on the set out of our reference lines and levels. Start by setting out a series of reference planes as per what's shown on screen. Once you have those drawn in, name the vertical references as follows. Once you've done that, you'll need to create some additional views to help with modeling. We'll essentially be modeling the 2 sides of the structure first, and then joining them together to complete the form. We'll need sectional references for this. Add one section at the top and then another at the bottom. We can now start to construct our model elements. We'll start at the bottom of the screen. Take notice of the section name here. On screen, I have this as Section 2. From the ribbon, find the Set tool from within the Work Plane panel. Choose the line shown on screen as the work plane. Revit will then redirect us to Section 2, where we can see that plane in elevation. Turn off any crop settings and then take the time to rename the levels. We can now draw on this plane. From the Draw panel, find Model Line. Start by drawing 4 horizontal lines which start and stop at each reference plane segment. Then repeat that at the bottom. So you should be left with 8 model lines, 4 on the top level and another 4 at level 1. When working with conceptual masses, it's helpful to refer to different views to get different perspectives on your model. In this view, we should be able to see the 8 model lines hosted to the workplane we selected earlier. Use the View cube to rotate the workspace. Now we need to select the model lines to create a form. But notice, as I drag the cursor, it highlights anything it passes over, which can make selection difficult. To manage this, pin down all references. This is best done with the Isolate tool. Once all elements are selected, pin them down and then deactivate pinned elements in the selection tray. Now you should be free to drag your mouse around without any interference from the pinned elements. And here I've missed one, so if I now pin this, it will no longer interfere with my selections. Speaking about selections, select one of the top segment model lines and its corresponding line below on level 1. Hit Tab to select the segments. With both lines selected, move up to the ribbon where you should select Create Form. This will present you with 3 form options. Select the last option. Repeat this workflow for the 3 remaining segments. So this is the work plane that we need to be projecting from. Once you are more experienced, you can skip this part. From here, go back to the sectional view we had open earlier. On this form, we are now going to draw a W shape as shown on screen. Ensure the sketch is enclosed on all sides. Check this by selecting the sketch. All line elements should be highlighted as per the screen demonstration. Moving along, revert back to the 3D view, where we can take the same selection and create an extrusion. Notice the coordinates indicator on the front face. We can use this to determine the depth of the extrusion. Ensure this snaps to the second horizontal plane. Simply click the corresponding arrow and drag to move. And this is what you should be left with. This would be a good time to save your progress if you have not done so already. Zoom into the W form. At this point, I'd like to remind you of something I spoke about at the beginning of the demonstration during the setup phase. And that is that the W shape we identified as a simplified version of the objective. This hopefully illustrates the importance of that step. Moving along, we are now going to look at vertices. Starting at the top corner here, click to select and you'll see those coordinate arrows again. Just like we did before, we will use our floor plan view to move this point. So now we are going to alternate back and forth from the 3D view and the plan view. You'll know you are doing this correctly when you start to see a helix in plan view. Then repeat the steps you've just used in creating your W shape on the top side of the project, but this time we are going to invert it to create an M shape. Let's take this opportunity to revisit the steps. Start by selecting the work plane that will host the model line sketch. This time we'll refer to section 1. This time we don't need the lofted reference plane because by now we should understand the concept of a work plane. Using the model line tool, sketch the M shape as demonstrated on screen. Once the shape has been drawn, revert to the 3D view where you can use the form tool to extrude. And just as we did before, we interchange between views to drag the coordinates icon to manage our extrusion. Then rotate the view cube so that we are facing the form, and zoom in to manipulate the vertices. Just keep in mind that the selection points are now inverted. I should point out that you can by all means move the coordinate icon in the 3D view. I just prefer using the plan view to ensure precision. Again, you should see the helix shape start to form. And the final step is to push out the edges, which for this shape go to reference line 3. We can now use those manipulated vertices as hosts for the spline tool. On the Draw panel, click Reference and then choose the Spline Draw tool. Now click on each of the points to create the inclined spline. This is done in 2 passes. First, the top segment as per the on-screen demonstration. Hit Escape once you get to the end and then repeat the command for the bottom selection. You should end up with something like this. Then spin around and do the same for the W shape. Remember to zoom in to make selection easier. Now let's pause and understand what we've created thus far. Orbit the view so that we are looking at the elevation of the model. This is also an opportunity to check the model and ensure that it's correct. In order for the next step to work, there must be a gap in between the top and the bottom spline here. Notice that on the left-hand side, that's not the case, so I'll have to redo this. It serves to show the importance of zooming in sufficiently to ensure accuracy. So I'll pick it up from a zoomed in view. I can select the defunct spline and delete it. This will also delete the hosting points. And I need to project this point to reference line 3. It's currently on reference line 2. Then I can recreate the spline. I'll check the elevation view again to ensure that it is as it should be. And it is, so now we can select both lines and loft these together using the Form button. Repeat this on the opposite side and then unhide to reveal the forms. To complete the structure, we can pick the top line of each side and then also loft these together. This concludes this step. Let's recap what we've done up to this point. First, we used the sketch to simplify the objective and establish set out references. We mapped out the references in Revit and then created a series of sacrificial forms from which we then created the inclined splines. The splines were then lofted together to create the form on screen. In step 5, we will transition into surfaces and prepare this for the future placing of slats. Start by selecting the bottom lofted form and convert this into a surface. Use the view cube to view the model in elevation. As shown, the current surface grid is not aligned to our reference planes. This is something we'll need to fix. However, before doing that, reset the currently selected grid using the Properties palette. We have removed all vertical grids. To proceed, from the ribbon, find Intersects List. This is a list of all the reference planes in the project, and we can use this to check off which of those reference planes we want to project onto our surface, essentially creating our own custom grid. The importance of this will unravel as the tutorial progresses. Now repeat this for the top lofted form. Notice, as this is converted into a surface, the UV grids are misaligned. However, using the Intersects tool that we have already used, we know that we can customize the grid by projecting reference planes. And now we have a perfect alignment between the top and the side of our model elements. To create the slat feature, we need to add more reference planes. So let's switch to plan view and set this out logically. Starting on the left side, select the first plane. This is called A1. Copy a second plane to the right. Add a distance of 1000 millimeters. Revit will give this an automatic name based on this reference plane, which was the last one we named earlier in the tutorial. Naming is sequential, so if we now come to this newly created line called A2, all preceding lines will contain the same convention, A3, A4, and so on. We will now project all of these onto the surfaces just like we did a moment ago. The importance of naming these logically ensures this is a smooth process. Now repeat this micro workflow for all remaining segments. Don't forget to rotate the view and also apply this to the back face of the model. In the next part of the tutorial, we'll understand why all of this was necessary. Select the surfaces as shown on screen and then on the options bar select the small down arrow. This is where we control the surface representation. Check Nodes. Do this for the top surface also. Because of the intersecting reference plane based grid, we now know that all of these nodes are aligned, enabling us to place our slats. This concludes this step. In this step, we learn how to create adaptive component families. Adaptive components are families that flex at specific points. This enables them to articulate over a model, such as this adaptive balustrade that articulates to accommodate a U-shaped stair. To create our adaptive component, we need a specific family template. We are looking for generic model adaptive. You'll notice that this looks very similar to the conceptual massing environment, but with one distinct difference that will be pointed out in a moment. Like we did with our mass, let's start with setout. Copy the center reference line out on either side 3000 millimeters. Then create an additional level by selecting the already existing level while holding Shift on your keyboard and dragging the mouse cursor up. Referring back to our model, there are 4 key points that we need to address. So let's go ahead and place 4 points. Let's set the bottom plane as the work plane. And then from the draw panel, find point and place it as shown. Then align this to the references, but don't lock. Then select the top level as the active work plane and place 3 more points. And then align these to the references as shown. With all 4 points now placed, select them all and move up to the ribbon. Then click Make Adaptive. This is the key difference using this template, as this feature is unique to adaptive templates only. This will number each point depending on the order they were placed. It's good to know that numbering can be changed at any point in time though, and this is quite easy to do. We now need to connect these together using a reference line from the Draw tool. Ensure Draw on Face and 3D Snapping are active. Now let's test the articulation by selecting a point and then selecting one of the colored arrows. The family is flexing correctly, so we can proceed by adding profile. To do this, add a new point and snap it to the midpoint of the upright reference line as shown. Now set this as the work plane horizontally. And then from the Draw tools, pick the model line rectangle. Click once to start the sketch and click again to finish. Placement is not super important because we'll use dimensions to set the profile size. Using a dimension, snap from one side to the other side of the profile, including the point. Now select the profile and tab to isolate selection to one profile line. Then edit the dimension values as required. Repeat this for all 3 remaining profile lines. Now we are going to sweep this profile along the reference plane to create our extrusion. This is super easy to do. Simply select both the profile and the reference path, noting that both lines of the path should be selected with one click. And then hit the Create Form button on the ribbon. It's always a good idea to flex the family again to ensure that it works as it should. That works well, so we can now load it into our model. It's now time to place the adaptive component. Here I have renamed my family according to how many points it has. And you'll see different variations on screen, but you can ignore these. Now to place the family, find it in the project browser and right click to see the drop down menu. Then choose Create Instance. Now place the family. following the numbered sequence of the adaptive points which were defined in the family editor. This is shown on screen to guide you. Use the nodes on the model as snapping points. Once one element has been placed, it can be repeated along the surface grid using this button, and this is the result. Well done on completing your dual dynamic mass. Give it a go yourself and let me know what you think. Remember that likes, comments and subscriptions go a long way in helping me give you more. Bye for now. That's the end of the video. I hope that you learnt something new and that you found it interesting.